Okay, point of application, and we studied the system of forces, coplanar, non-coplanar. Now the other part of the next further the next subject is resolution of forces. A force can be resolved into two component forces graphically or with use of trigonometry. So in our this thing we represent with graphically, or and for solving the problem we follow the trigonometrical relations, okay, sin theta, cos theta and tan theta, to get the magnitude of resolution and the direction of the resultant, magnitude of resultant and direction of the resultant. Now what it allows us to analyze the causes of a motion separately, vertical and horizontal direction. We can resolve the components into horizontal and vertical components. How it is? Force R, which makes an angle theta with x axis, and we have to observe where the force is making an angle with the x direction. Now we can resolve the forces into x axis and y axis, and the components are r cos theta and r sin theta. Now before that, first we have to observe, see the difference in the this picture. The theta is making angle with respect to x axis. Either we can follow the first one, and or we can solve the problem with the second one, sign convention of the forces. Any of the things we can follow to solve the problem. Here the major thing is, while solving the problem, our aim is to calculate the magnitude of resultant force and the direction of the resultant. The direction of resultant means theta, tan theta we have to find. That we will learn in the next slides. Coming back to this, now the force R is making an angle with the x axis, that is horizontal x axis. The forces resolved are r sin theta and r cos theta. Here we are going to resultant of a number of coplanar forces. We follow any of the methods to calculate those resultant and angles or the directions. Take the first one, forces F1 and F2, F3 acting at O. We can see here F1, F2, F3. Theta 1, theta 2, theta 3 angle made with the x axis respectively. Okay, theta 1 for F1, theta 2 for F2, theta 3 for F3. And you can observe the sign convention also. H is the horizontal component of force along x axis, and we can resolve the forces, the horizontal forces, F1 cos theta 1, F2 cos theta 2 and F3 cos theta 3, and V is the vertical component of force along with y axis. That we can do it on the board. We will try to solve it on the board. V is equal to F1 sin theta 1 plus F2 sin theta 2 and F3 sin theta 3. As I told you, our aim is to calculate the resultant, and angle made by the resultant R with x axis theta, that is a direction. That is a this is the formula. This is a trigonometrical formula where we can calculate the resultant of the force and angle theta, hypotenuse and some of the horizontal and vertical forces. As you know, hypotenuse square is equal to horizontal square and vertical square when we resolve the forces. So before going to the moment of force, let us work out some of the problems, how we are going to calculate the resultant of the force. Y axis, x axis. As I told you, force R with the direction or making an angle with theta. Okay, and this can be resolved into two forces, that is a vertical component and horizontal component. when you draw the triangle R, this is a horizontal component and this is a vertical component with an angle theta. Now we'll resolve the forces. How we calculate this, the horizontal component? As we know, sin theta is equal to opposite by hypotenuse, cos theta equal to adjacent by hypotenuse, and tan theta is equal to adjacent by hypotenuse. This is the adjacent side, this is opposite side and hypotenuse. Now as I told you, let's calculate this horizontal component. Horizontal component is the adjacent side of this triangle. Now we will calculate the horizontal component h. What is h here? H is equal to, as we know, it is cos theta is equal to adjacent by hypotenuse. Here adjacent side is h and hypotenuse is r. So therefore, to calculate the h, the horizontal component, r cos theta is our horizontal component. H is equal to r cos theta. Now similarly, we want a vertical component which is in the opposite side. We take sin theta. Sin theta is equal to opposite by hypotenuse, and that is equal to what? Opposite is vertical component, hypotenuse is r. So therefore, vertical component is equal to r sin theta. So V is equal to r sin theta. Now, if the force R makes an angle with y axis, the vertical, we can resolve the forces into vertical and horizontal. This is V, this is H, this is R. Now if we consider the triangle here, the angle made by the force R with y axis or vertical, here we can observe here, this is the horizontal component, this is vertical component. Now this will be opposite and this will be adjacent, and it was vice versa in the other case when it is making an angle with a theta. Now if we take this here, H is equal to F sin theta and V is equal to F cos theta. Now check this, H is equal to R sin theta and V is equal to R cos theta. I'll repeat once again. Here the force R is making an angle with theta. Okay, the horizontal components V is equal to R cos theta and H is equal to R cos theta and V is equal to R sin theta. You can observe here. This similarly, if the force is making an angle with a vertical y axis, the horizontal component will be R sin theta and vertical component will be horizontal component will be r sin theta, vertical component will be r cos theta. So this where we have to concentrate, whether the force is making an angle with the x axis or the y axis. We have to concentrate on that portion. Now let us take one simple problem. X axis, y axis. The force of 150 Newton making an angle 30 degree with x axis. This is a point to be noted. Now resolve the forces. This is vertical, this is a horizontal component. As I told you, force making an angle with x axis, the horizontal component will be what? H is equal to F cos theta. As earlier I told R, now we can consider F as F cos theta and F sin theta. Solution. What is the given data? Given data is force F equal to 150 Newton, theta or angle made by the force theta is equal to 30 degree. Horizontal component, H is equal to, as I told you, F cos theta, that is 150 Newton cos 30 degree, we get 130 Newton. Unit is Newton. The unit of forces, we can take Newton, kilonewton or even kg. Now what about horizontal component? What about vertical component? Vertical component will be V is equal to F sin theta. Here you can observe there F is equal to 150 sin 30 degree, and the answer is, here it is 75 Newton. This is a very simple problem where we resolve the forces into horizontal and vertical components. Now let us consider the other next problem. First one is 15 kilonewton force which makes an angle theta equal to 30 degree, and 55 kilonewton force which makes an angle 60 degree or 70 degree, not 60, 70 with the y axis. We will resolve the forces. Vertical force, horizontal force. Now vertical and horizontal. Major difference between the first problem and the second problem, here the theta angle makes the force make an angle 30 degree with x axis,